go for presentation. Well, can you see the screen? Okay. Just say yes. Okay. Hello.
Yes, sir.
Yes. Okay. So I wanted to discuss few questions from yesterday's. First of all, question number 9. What is the minimum number of zeros in a diagonal matrix of order 3? Well, in a matrix of order 3, square matrix of order 3. See, diagonal matrix as such essentially is a square matrix of order 3. There are 9 elements. In a square matrix of order 3 with 9 elements, 3 are diagonal elements, remaining 6 are non-diagonal elements. So minimum all the non-diagonal elements must be 0. You know, you cannot have a non-zero matrix. You cannot have a non-zero element. You cannot have a non-zero element in non-diagonal elements. Minimum how many zeros? Minimum. I'm talking about minimum. The second part. What is the minimum number of zeros? Can some of you tell me? 6 zeros must be there. Now what about maximum zeros? Even the diagonal elements I can admit zeros, but not all zeros. But not all zeros. So what is the maximum number of zeros?
8.
8 zeros, exactly. Maximum 8 zeros, minimum 6 zeros. Now let us look for the third part. What is the maximum and minimum number of zeros possible in a diagonal matrix of order n? In a diagonal matrix of order n, there are n squared elements in which n are diagonal elements. There are n diagonal elements. So minimum there must be n squared minus n zeros. Minimum. Maximum zeros, n squared minus 1. I can have all zeros except at least one non-zero must be there in the diagonal. There may be all the rest zeros, but at least one. So maximum number of zeros will be n squared minus 1, and minimum there should be n squared minus n. Okay, now further we have, here we have one more question here, that is question number 10. Question number 10, I think you solved it. Question number 11. Many of you have solved it, but many of you have not got the answer. Many of you have expressed doubt. Well, there are equations. 4 equal to 4, there is no equation. X minus y equal to 3x minus y. 2y equal to y squared minus 3. X plus y equal to 6. Look at the first equation. X minus y equal to 3x minus y. When I say x minus y equal to 3x minus y, can you write it? Minus by minus by cancels. X equal to 3x. That means 2x equal to 0 or x equal to 0. And when x equal to 0, from the equation below, that is x plus y equal to 6, you get y equal to 6. X equal to 0 and y equal to 6. But remember that when x equal to 0 and y equal to 6, it doesn't satisfy the other equation. 2y equal to y squared minus 3 is not true when y equal to 6. Are you getting? There is no x and y which satisfy these two matrices equal. You have to be very careful. And further you have the question number 13. Again the same kind. Look at, from the last equation you get y equal to 1, fine. And from this 2x plus y equal to 5, you get x equal to 1. So y equal to 1, so x equal to 2. But that x and y will not satisfy x plus 2y equal to 3. Will not satisfy x plus 2y equal to 3. So there also, there you can say that there is no solution. Solution does not exist. Is it clear? So these are kind of questions which you may encounter. You have to be very careful. You may simply say, come on here, y equal to 1, and putting y, you get x equal to 2. But see, that has to satisfy the whole equation, all the equations. Okay, that is a simple thing. I think it is clear now. We go for further. Okay, we go for multiplication of matrix by a scalar. Here, when I say scalar, anything which some numbers, which is not matrix, some real number or complex number, here we refer as scalar. Scalar means simply number, maybe real number, maybe complex number. Here we are mainly dealing real numbers. So multiplication of a matrix by a scalar. We have seen addition of matrices today. Here we are now multiplication by a scalar. If A is equal to Aij, could be any order. Let me say matrix of order m by n. Then and k is a scalar. That is what I call k is a number, maybe real or complex. Then Ka, remember Ka is not a matrix, K is a number which we call scalar here. Ka is the matrix obtained by multiplying each element by k. It again will be a matrix of the same order, obtained by multiplying each element by the number k. Okay? Multiplying each element by the number k. Very simple. Well, if A is equal to Aij, m by n, then Ka. Each element when I multiply with k, I get Kaij. Order is not changed. No matter whatever is k. I did not specify whether k is 0 or not 0, nothing to do. K may be 0, k may be not 0. For example, if A is equal to, is a 2 by 3 matrix, 1, 4, 2, minus 3, 2, 0. What will be 2A? Order is not changed. Each element will be multiplied with 2. I get 2. Can you understand? I'm multiplying each element by 2. First element, when I multiply with 2, I get 2. Then row wise, if I speak 8, I'm getting third element will be 4. Further, we go to second row, minus 6, 4, and 0. That is 2A. A given 2A. Now we'll take more problems on the way. Before that, let's discuss what is negative of a matrix. Negative of matrix. Negative of a matrix A simply denoted by minus A. Okay, which is nothing but minus A will be simply minus 1 into A. Minus 1 into A. Each element will be multiplied with minus 1. For example, if A is equal to the same matrix 1, 4, 2, minus 3, 2, 0. Then what is minus A? It will be row wise minus 1, minus 4, minus 2, 3, minus 2, 0. Minus 1, minus 4, minus 2, 3, minus 2, 0. Agreed? Clear? What is a multiplication by a scalar and what is the negative of a matrix? We can simply define the difference of two matrices. If A and B are matrices of the same order, then the difference A minus B, actually we are subtracting, but we can define A minus B is again a matrix of the same order, where A minus B is A added with minus 1 into B. Simply, no need to worry about that. You can simply what is A minus B. If you have A and B, A is 1, 4, 2, minus 1, minus 3, 2, 0. B is 3, 2, minus 5, and 4, 1, 2. Can you tell me what is A minus B? Very simple. 1 minus 3, that is minus 2. 4 minus 2, that is 2. 2 minus 5, that is 7. Minus 3 minus 4, that is minus 7. 2 minus 1, that is 1. And 0 minus 2, that is minus 2. Very simple. Subtraction of matrices. So we know how to add matrices, we know how to subtract matrices, we know how to find the negative of a matrix, we know how to multiply a matrix with a scalar. That's what we call scalar multiplication of matrix. What about 2A minus 3B? Here we are multiplying A with 2, then B with minus 3 and add, or b with 3 and subtract. What is 2a? 2 into a minus 3 into b. What is that? 2a. 2a will be 2, 8, 4. 2 into minus 3, minus 6, 4, 0, minus. What is 3b? It's 9, 6, minus 15, 12, 1, 3 ones are 3, 6. So 2a minus 3b, what is that now? 2 minus 9, minus 7, you can easily see. 8 minus 6, 2. 4 minus 15, that is 19. Minus 6 minus 12, that is minus 18. 4 minus 3 is 1. And 0 minus 6 is minus 6. Any questions? Any queries? Let us go for some properties of matrix addition. Well, matrix addition, you can easily see it is commutative, that is a plus b equal to b plus a. No need of a proof, simple understanding. A plus b equal to b plus a. Matrix addition is commutative. Further, it is associative. Whether you add b plus c and add with a, or you add a plus b and add with c, both are same. Matrix addition is associative. Further, for a of order m by n, we get a zero matrix of the same order, so that a plus o equal to o plus a equal to a. Actually, it is the property of additive identity. Here the matrix O is the zero matrix or identity of addition of the same order. O is called the additive identity of the matrix of that order. This O depends on the order of the matrix A. Right? If A is m by n, O is also same order m by n. So this is the existence of additive identity. Further, for any matrix A equal to Aij, we get minus A. You know what is minus A? It is minus Aij. So that A plus minus A is zero matrix. That is minus A plus A is zero matrix. This is actually the existence of additive inverse. The additive inverse of matrix A is minus A. Properties of scalar multiplication, I am writing together because it is easy to understand. For matrices A and B and scalars K and L, K into A plus B is Ka plus Kb. K plus L into A equal to Ka plus La. K into La is Kl into A. Alright? You can also write 1 into A equal to A. That is obviously understood. That is why I did not write. If A, let us take few questions. If A is equal to 2, 3, 1, 5, and B is equal to 3 minus 1, 2, minus 2, these are 2 by 2 matrices. Find 2 by 2 matrix so that, find 2 by 2 matrix C so that 2A minus 3C equal to B. 2A minus 3C equal to B. Well, what we have is 2A minus 3C equal to B means what will be 3C? It will be 2A minus B. What is 2A minus B? 2A is 2, 3, 1, 5 minus B. 3 minus 1, 2 minus 2. 2A, that is 4, 6, 2, 10 minus 3 minus 1, 2 minus 2. Tell me the answer. 4 minus 3, 1. 6 minus minus 1, 6 plus 1, 7, 2 minus 2, 0, 10 minus minus 2, 10 plus 2, that is 12. So 1, 7, 0, 12. Correct? This is 3C. So what is C? You have to divide with 3. That is 1 by, you have to multiply with 1 by 3. 1 by 3 in this matrix, you can keep as such, that's no problem. Or you can multiply each element with 1 by 3. So the matrix can also be written as 1 by 3, 7 by 3, 0, and 12 by 3, which is 4. Okay? You got a matrix C so that 2A minus 3 is equal to B. Well, A and B are equal to 2 by 2 matrix. Let's go for next question. Find 2 by 2 matrices A and B so that You are going to have a matrix equation now. 2a plus b is 3, 4, 1, 0, and 3a plus 2b is minus 5, 7, 4, 3. It is something like solving system of two linear equations. What are the given equations? 2a plus b equal to 3, 4, 1, 0, and 3a plus 2b equal to minus 5, 7, 4, 3. Well, just like solving two linear equations in unknowns a and b, you can eliminate b easily. How do you eliminate b? You multiply the first equation throughout with the coefficient of b here, that is 2. If you multiply the equation 1 with 2, I get 4a plus 2b equal to 6, 8, 2, 0. And then by subtracting b get cancelled, you get the value of a. So equation 1, so that you have to discriminate what you have to do. Okay? Equation 1 multiplied with 2, you get 4a plus 2b. Right side when you multiply with 2, you are getting 6, 8, 2, 0. Now we are going to subtract. 2 minus 3 or 3 minus 2 also like here I am taking 2 minus 3. 2b goes, 3a minus 4a will be minus a. And when we subtract, remember I am subtracting. Minus 5 minus 6, that is minus 11, 7 minus 8, minus 1, 4 minus 2, that is 2, 3 minus 0, that is 3. So what is a? A will be 11, 1 minus 2 minus 3. 11, 1 minus 2 minus 3. Now we need b. We can depend on or look into equation number 1. What is b? B will be 3, 4, 1, 0 minus 2a. B will be 3, 4, 1, 0 minus 2a. That is 3, 4, 1, 0 minus 2a. What is 2a? A you multiply with 2. That will be, where is a? A is here. A is here with us. 11, 1 minus 2 minus 3. So what is 2a? 22, 2 minus 4 minus 6. So 11 minus 2a. A is here with us. A we found out. Now we make the subtraction. 3 minus 22, that is minus 19. 4 minus 2, that is 2. 1 minus minus 4, that is 5. 0 minus minus 6, that is 6. We have p equal to minus 19, 2, 5, 6. You got p. So we solved the two linear equations in two unknowns a and b. The usual elimination method we applied. We are using that method comfortably. Let's take one more. Find 2 by 2 matrices a and b. I think you are getting the grip now. 3a plus 5b equal to I, and 2a plus 3b equal to 2, 5, 3 minus 1. Here I means 2 by 2 identity matrix. Because we are dealing 2 by 2 matrix, I without specifying any suffix, it is an identity matrix where these can be equated, so that identity matrix will be 2 by 2. 2 by 2 identity matrix. So we have 3a plus 5b. So given 3a plus 5b equal to 1, 0, 0, 1, that is equation 1, and 2a plus 3b is equal to 2, 5, 3 minus 1. Well, equation number 2, you have to eliminate. And eliminate a first, then you get b, and then from there you get a. So to eliminate a, what we do is that first equation multiply with the coefficient of a in the next, if you want to eliminate a. If you want to eliminate b, first equation multiply to 3, second equation multiply to 5. Here I find it more comfortable to eliminate a. So first equation multiply to 2, I get 6a plus 10b equal to 2002. Now second equation I multiply to 3, I get 6a plus 9b equal to, multiplying to 3, 6, 15, 9 minus 3. 6, 15, 9 minus 3. That is equation number 4. What do you do now? Equation 3 minus equation 4. 6a goes, okay, stuck in, or is it not out? 6a goes, 10b minus 9b, that is b is equal to, subtracting equation 3 minus equation 4, you get minus 4, minus 15, minus 9, 5. 2 minus minus 3. You got B. Now, having got B, what A? Which equation you consider? I think I'll better consider equation 2. Equation 2 gives 2A equal to 253 minus 1 minus 3B. But we have B here. What is 3B? 3B will be minus 12, minus 45, minus 27 and 15. Okay? 253 minus 1 minus 3B. Now simple calculation. 2 minus minus 12 is 14. 5 minus minus 45 is 50. 3 minus minus 27 is 30. 1 minus 15 is minus. Minus 1 minus 15 is minus 16. That is 2A. So what is A? 7, 25, 15 minus A. You got A and B. Is it clear now? Let us go for some questions for homework. A is given and B is given 3 by 3 matrix. You have to find the 3 by 3 matrix C so that 3A minus 2B plus C equal to I. Here naturally I is I3. I don't need to specify because A and B are 3 by 3 matrices. What will be C? Simply I minus 3A plus 2B. A and B are given 3 by 3 matrices. Find the 2 by 2 matrices A and B. Find the 2 by 2 matrices A and B so that 3A plus 7B equal to 2, 1, 1, 5. 2A plus 3B is equal to 5, 3 minus 2, 5. You know how to solve the two linear equations. Eliminating one variable, you find the other, and from there you find this. Find the 2 by 2 matrices X and Y so that 2X plus 3Y equal to 2 minus 1, 1 minus 3. Again, the same kind of equation you have to solve, get in practice. If A, B, and C, find X and Y so that, see, remember, it is again unknowns X and Y are there. You have to find X and Y so that 2A plus B equal to C. You have to form equations and solve for X and Y. 2A plus B. 2A plus B equal to C. 2A plus B equal to C. Okay? Have a nice day. But remember, what is